So what if, instead of just trying to kill our deadliest infections, we could outsmart them? Today, we're diving into an incredible story of biological engineering, where scientists literally programmed a bacteria to pull off a microscopic heist and stop a deadly infection in its tracks.
All right, here's how we're going to break it all down. First, we'll talk about the deadly problem, this paradox we've created. Then, we'll meet our engineered hero. We'll get into its super clever plan, how it hacks the system. Then, we'll look at the absolutely stunning results. And finally, we'll zoom out and ask, what does this mean for the future of medicine? So, let's start with the villain of our story. It's a bacterium called Clostridioides difficile. We just call it C. diff for short. And it is a master at turning our own best weapons against us.
Yeah, take a look at this number, 20,000. That is how many people die from C. diff in the United States every single year. So no, this isn't some minor bug, it's a massive public health crisis.
And the scale of the problem is just huge. We're talking 500,000 infections a year, mostly hitting people when they're already vulnerable in hospitals. But the real nightmare, the truly vicious part, is the paradox of how we treat it. And this is that vicious cycle right here. A patient gets an infection. What do we give them? Antibiotics. But those antibiotics are kind of like carpet bombing your gut. They don't just kill the bad guys, they wipe out all the good bacteria too. That chaos is called dysbiosis, and it basically rolls out the red carpet for C. diff to kick over and come back again and again.
And here's why it's so tough to get rid of. C. diff has this incredible survival mode. It forms these super resilient spores. Think of them like tiny dormant seeds. They can survive anything, antibiotics, stomach acid. They just wait patiently for the gut to get wrecked, giving them the signal to wake up and attack.
So, what do you do if your main weapon actually makes the enemy stronger? Well, a team of scientists decided to change the rules of the game. Instead of building a bigger bomb, they built a microscopic secret agent, a smarter weapon. And let me be really clear here. This is not about eating more yogurt. Those are what you might call dumb probiotics. They give you some general support, and that's great. But what we're talking about here is taking a totally safe, well-known probiotic and installing a genetic circuit board inside it, turning it from a simple bacteria into a smart biological machine with one very specific mission. And this shows the whole strategy perfectly. So, step one. Our little engineered spy senses a chemical signal that basically screams, the gut is in trouble. Step 2, that signal flips a switch and activates the probiotic. And step 3, it gets to work. But, and this is so important, it doesn't try to kill C. diff. It just makes sure those dormant seeds can never, ever sprout. So inside this living machine is a clear piece of code. It's a simple if/then statement. If the sensor detects high levels of a sugar called Sialic Acid, which is the big red flag for gut damage from antibiotics, then it boosts that signal and tells the actuator to release its payload, a very specific enzyme. It senses the problem, then it acts. It's pure programmable logic.
Okay, now we're getting to the most elegant part of this whole plan. The probiotic doesn't get into a fistfight with C. diff. It wages a really subtle chemical war to make sure the enemy stays asleep. Permanently.
So to get how this hack works, you need to know what wakes up those C. diff spores in the first place. They need a chemical key to turn the ignition. For C. diff, that key is a bile salt called Taurocholate. And guess what skyrockets in a gut that's been destroyed by antibiotics? Yep, Taurocholate. The best way to think of this is like a traffic light. Taurocholate is a giant green light for C. diff. It tells the spores, go, 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 wake up and infect. But the enzyme our smart probiotic releases, it performs one simple chemical trick. It converts that green light, Taurocholate, into another bile salt called Cholate. And Cholate, that's a big, bright red light. It tells the spores, nope, stay asleep. So that's the whole magic trick right there. The smart probiotic is a chemical switch flipper. It senses the danger, and then it systematically rewires the environment. It takes away C. diff's alarm clock and replaces it with a do not disturb sign. It's just a beautiful, indirect strategy. So it's a brilliant plan on paper. But as we all know, biology is messy. It's unpredictable. So the ultimate question is always the same. Did this clever hack actually work in a real live infection? Well, to find out, they turned to the standard mouse model for C. diff infections. They gave one group the fully engineered probiotic and compared it to a control group that got the infection but no treatment. The results? Well, you just have to see them. 100%. That was the survival rate for the mice with C. diff that got treated with a fully programmed smart probiotic.
Let's really put that in perspective. The results were just jaw-dropping. The smart probiotic group had a 100% survival rate. The control group, the one that got the infection and no help, only 14.3% of them survived. In medical biology, you do not see 100% effectiveness. It's almost unheard of. It's absolute proof of how powerful this strategy is.
But here's the real clincher. Here's how we know the smart part was essential. They also tested versions of the probiotic with broken circuits, one without the sensor, for example. And guess what? They failed. They didn't protect the mice. So this tells us that just dumping the enzyme in the gut wasn't enough. The probiotic had to be intelligent. It needed that complete circuit to sense the environment and act at just the right time. So what does an incredible result like a 100% survival rate really mean, beyond just C. diff? Well, it's a massive proof of concept. It points toward an entirely new way of thinking about how we treat disease.
The fancy name for it is host pathogen microenvironment modulation. I know, it's a mouthful, but the idea is actually pretty simple and totally revolutionary. Instead of launching a direct assault on the pathogen, we become intelligent gardeners of our own bodies. We just tweak the environment so the bad guys can't grow in the first place. And this really is the shift in thinking. For the last century, medicine has been about carpet bombing with antibiotics, causing all sorts of collateral damage. This research gives us a glimpse of a new era, the era of biological snipers. Living medicines, programmed with logic, sent on a single, precise mission with zero collateral damage. You see, this successful mission against C. diff is so much more than a win against one bug. It's a blueprint. It asks this incredibly powerful question about the future of medicine. What other diseases, what other huge challenges could we solve not by waging war, but by programming life itself to restore balance?